Hi, this video will show the heat transfer function derivation for the second order system, which is system in series with the interacting tank. So here we have two tanks, okay, with the area A1 and A2 and the height H1 and H2, and we have the inlet QT and the outlet Q2. The mass balance for tank 1 and tank 2 as below here. Q1 Q minus Q1 equals to A1 dH1 over dt. Q1 is equals to 1 over R1 multiplied H1 minus H2. Q1 minus Q2 equals to A2 dH2 over dt, and Q2 equals to H2 over R2. This one is the equations for the tank 1. This one is the equation for the tank 2. So what I can see here, H1 is larger than H2 from these equations. So we have to derive the transfer function for this system in series interacting tank. Let's start the derivations. Okay, for the tank 1, what we have is Qt minus Q1, which is equals to A1 dH1 over dt, as per stated here. So I can rearrange these equations. Qt minus H1 minus H2 over R1 by substituting this Q1 inside these equations. So we get this form equals to A1 dH1 over dt. So I label this as equations number 1. So we go to the tank 2. Whereas tank 2 is Q1 minus Q2, as per stated here, equals to A2 dH2 over dt. So I can substitute the related equations here, which is Q1 and Q2, in these equations. So it becomes H1 minus H2 over R2. Sorry, this one not R2, is R1. Okay, so minus Q2 is H2 over R2 equals to A2 dH2 over dt. Okay, so if I introduce this as a deviation variable, so at the steady state conditions, I can write as H1s minus H2s, as to indicate this one is in steady state, R1 minus H2s over R2. At steady state, dH over dt is equal to 0. There's no change at steady state. So I can rewrite this again to consider the derivations variable. Okay, so it becomes H1 minus H2 over R1 minus H1s minus H2s over R1, which is these equations. Okay, deduct these equations minus this equation at a steady state. So it become this form minus for the second term H2 R2 minus H2S to indicate the steady state, the S, this one for the second term, then is equals to A2 d H2 minus H2S equals to divide by over d dt, which is this term. Okay, so when I already introduce the derivation variable, I can write this in capital letters H1 T, right, minus H2T over R1 minus H2T over R2 equals to A2 dH2 dt. Okay, so this one is at the t, yeah. Okay, so we can apply Laplace transform. Then what we get is H1S minus H2S over R1 minus H2S over R2 equals to A2S H2S in the S domain. So we get these expressions. Okay, let's continue with the derivations. I will take these equations, okay, and I will rearrange these equations. Okay, let's write these equations again. H1S minus H2S over R1 minus H2S over R2 equals to A2S H2S. So I can rearrange these equations. H1S minus H2S over R1 equals to A2S H2S plus H2S over R2. I bring this term to the right hand side, and I also can write this in the factor form. I can factorize this. I can take out H2S multiplied by A2S plus 1 over R2. So I can write in this form. Then I can rearrange this again. H1 S minus H2S, which is equals to this one. I bring it to the right hand side, R1 over R2. I can factorize all of this. R2 A2 S plus 1 divided by H2 S. Okay, so I label this as equation number 2. When I proceed to rearrange this H1S, I write H1S in terms of all of this. So it become R1 over R2. Okay, so I define this R2 A2 as tau 2. Tau 2 S plus 1 H2S plus H2S. So I label this as equation number 3, where, as I mentioned, tau 2 is equals to R2 multiplied by A2. Okay, so from the equations number 1 in the previous calculation here, okay, so at a steady state, we know this one at steady state, okay, Qs is minus H1s minus H2s over R1 equals to 0. This one is from the previous equation 1. Okay, so when we apply deviation variables, so we will get Q2 Qt minus H1t minus H2t over R1 equals to A1 dH1t divided by over dt. Okay, so I can apply Laplace transform here. So what I get is Qs minus H1s, okay, minus H2s over R1 equals to A1s H1s. Okay, so we can see here, okay, we have the terms of H1 minus H2s. We also have a term which is H1s. So from these equations, we can substitute equation 2 and 3 into these equations. So here the terms that I can substitute, the equations 2 here, and this one I can substitute the equations of 3 here. Okay, okay, let's continue with the derivation. So we already got these equations, which is Qs minus H1s minus H2 over R1 equals to A1 as H1s. So we will proceed to substitute equation number 2 and equation number 3 into equation number 4 here. Okay, I rewrite again the equations. So the equations that we got is Qs minus H1s minus H2s over R1 equals to A1s H1s in the S domain. So what we want is we want to substitute this and this in the equation that we have derived, which is the equation 2 and equation 3, into this equation 4. So we just substitute Qs, okay, minus, okay, R1 over R2, okay, check again the previous equation, okay, to see what is the equation that we have derived for equation 2, which is R1 over R2 multiply R2 A2 S plus 1 and then H2S, right? This one is over R1, which is this one, okay, and is equals to A1S. Then we look again what is the equation 3. H1S is equals to R1 over R2 tau 2S plus 1 H2S plus H2S. This is the equation when we substitute. Okay, and we also have defined that T tau 2 is R2A2. So for this term, we can write it as a tau 2. So I just rewrite this again and cancel where it's necessary. So I can cancel this, I can cancel this. So I can write this equation as qs, okay, minus 1 over r2. I just simplified this because we already defined t2 earlier, tau 2 earlier as r2 equal r2 multiplied by a2. So r2 multiplied by a2 is tau 2 s plus 1. So I just write again h2s here, and this one is still the same, a1 s, okay, r1 r2, okay, tau 2s plus 1, h2s plus h2s. Okay, so what we want to see here is we try to write qs in terms of everything here, and we see we have h2s here, we have h2s, we have h2s, right? So I can write this in the form of qs equals to this one. I move to right hand side, so it become 1 over r2 tau 2s plus 1 h2s, the first term for h2s, plus a1s. This one I just write again in the form that I want to split this, because this one is factors, so I want to see the h2s here, okay, as, then I can write as r1 r2, okay, then it's tau 2s plus 1, this one h2s, then plus a1s h2s. Okay, so I try to factorize everything here. qs, okay, it's quite a lengthy derivation. h2s, factorize everything here. Okay, so this one I can write as a tau 2s plus 1 over r2. Okay, so for this term, for the second term, I can write as r1 over r2, okay, tau 2s plus 1, okay, so a1 s, okay, so I write it that way, plus a1 s, okay, don't forget the s, yeah, okay, so I can rewrite this again for this term, okay, qs equals to h2s, so I write in the form that easy to look, tau 2s plus 1, and then this one I can write as, okay, r1 a1 s, right, and then tau 2s plus 1, okay, and this one I can write as 1 a1 r2 s, okay, so it's over r2. Okay, so if you check, this one will be tally with this one, this one will be tally with this one, the terms, right? So everything is tally with this term, and same with the last term here, a1s. Okay, once you reach at here, so for here we have this r1 a1, so I can define this as a tau 1, which is a1 r1. Okay, so I can reduce, okay, the alphabets here, okay, by putting it as a tau, okay, because it's at the head s here, the coefficient, this one is the coefficient, so I define this as a tau. So we proceed when we have that, so I can write this term as qs equals to, I can write again this term I can write this H2S here. So I can just simplify this as tau 2s plus 1, okay, plus, okay, tau 1s, okay, having s there. So then tau 2s plus 1, okay, this one then remain as a1 r1, a1 r2 as this one over r2, yeah. Okay, so I try to write it as a tau 2s plus 1 and then plus tau 1 tau 2s power of 2 plus tau 1s, right? This one I just multiply this one plus a1 r2 s over r2. Okay, don't forget this h2s. So we get something like this one. So we can see that this one is something related to the second order system. So we proceed this one. Okay, so we get this qs equals to this long equations here. So we try to write this one in terms of q over h2s. So when we write as a q, okay, sorry, we try to rearrange this for the outlets, the inlets. H2s over qs is r2 over tau 2s plus tau 1s plus a1 r2 s plus tau 1 tau 2 s power of 2 plus 1. Okay, so we can rearrange this again to r2 over, try to factorize this, tau 2 plus tau 1, okay, plus a1 r2 s, right, plus tau 1 tau 2 s power of 2 plus 1. So this one is already in the form of standard form of the second order system. So if we look at this equation at the denominator, they are the presence of the cross product, okay, which is a1 multiplied by r2. So this one will, this term, okay, will give the sluggish response to the system. Okay, so this one is our final transfer function for h2s over qs. Okay, so thank you so much.